project name is Compact Autonomous Sewage Cleaning Machine with Satellite Roadmap Extraction. Our non-model ID is NMNTSTD951201119. My name is S.SASI REKHA. My team number name is A.ANISHAPUSHPAM, M.VENUKA, and T.SAKTHIVELAMMAL. Our mentor is Dr. E.A. Muhammad Ali, Assistant Professor of AC Department, IQAC Coordinator. Our theme is Rural and Urban Development Manufacturing Engineering Technology, and our problem statement is how might we design a compact, cost effective device to efficiently clear long sewage canals and remove stagnated water, improving drainage flow and preventing blockage in a sewage system. Our objective is automated sewage cleaning to reduce human risk, use satellite mapping for real-time route planning, improve efficiency with obstacle detection, reduce costs using energy-efficient technique, and prevent blockages and urban water pollution. The compact autonomous sewage cleaning machine works based on four main technologies. First, autonomous navigation. The machine moves on its own using sensors and microcontrollers. It avoids obstacles and follows the path without human control. Second, satellite roadmap extraction. The system uses real-time GPS and GIS data to extract the roadmap and plan the cleaning route. This helps the machine move through the correct sewage lines. Third, screw conveyor mechanism. Inside the machine, a screw-type conveyor lifts and collects solid waste from the sewage and stores it in a bin. Fourth, real-time monitoring and reporting. The system monitors its working using sensor. When the cleaning is complete, it sends a status message to the control center. If there is a fault or blockage, it sends a warning. In one line, the machine combines autonomous movement, satellite guided path planning, mechanical waste collection, and live monitoring to clean sewage without human effect. Thank you.
This picture shows. Here we start with the original satellite image on the left. It contains all colors and details, like buildings, roads, grass, and vehicles. To process the image easily using computer vision, we first convert it into grayscale, which is shown on the right. This removes all colors and keeps only brightness information. Grayscale makes it easier to detect roads and edges in later steps, like thresholding and edge detection. This image shows. After converting the image to the grayscale, we apply thresholding to create a binary image, shown here. In a binary image, each pixel is either black or white. This helps clearly separate the roads from the background. Thresholding simplifies the image so that only the important structures like roads are visible for the next steps, like edge detection and extraction. This image shows us after thresholding, the image still has noise and small unwanted details. To clean this up, left image, median filtered image. A median filter is used to remove noise while keeping the edges sharp. This helps reduce small dots or speckles. Right image, morphological filter image. Then we use morphological operations to dilation or erosion to highlight the root structures clearly and connect broken parts. This slide shows a quality comparison of our post-processing step. On the left is a closed image. Notice the continuous row network after morphological closing. The middle panel is a raw binary mask where minor gaps remain. Finally, on the right, we overlay the closed mask and the original scene, confirming that our extracted vectors coincide with actual road waves. This visual evidence supports the quality metrics. This slide shows the performance of a roadmap extraction model. The left side displays the model reported accuracy, which is 94.3699%, suggesting high reliability in detecting roads from images. Beside that, the confusion matrix shows values that evaluate how well the model distinguishes road pixels from non-road pixels. The lowest numbers in the diagonal of the matrix indicate good classification accuracy. At the bottom, two sets of image compare results with and without using a double function step in the algorithm. The image on the left shows outputs when the double function is applied, and the image on the right shows output without it. Visually, the images with the function seem to produce clearly and more continuous root structures, demonstrating the effectiveness of the step is enhancing extraction results.